I've bought a load of cheap DRAM chips from China. .4116 and 4164 chips, good for retro repairs. I'm not sure if they're real though, so we're going to build a DRAM tester. Right now. Mark fixes stuff. This is a dual DRAM tester by Stephen Vickers from PCBgeeks.com. It comes in kit form. The brains of the unit is an Arduino Nano and it arrives pre-programmed. Let's untangle this tape. Hiding underneath is a 7660 voltage converter, presumably to generate the negative voltages. We'll put that to one side. Next out of hiding is a 16-pin ZIF socket for the 4116 parts. Swiftly followed by another, this time for 4164 testing. The board is good quality and looks like an easy build. In the components bag is a mix of through-hole and surface mount parts. Let's put the board into the PCB holder and get ready to start soldering. PCB holders are not essential, but really help with smaller boards like this one. Even new boards can be dusty or greasy with fingerprints. I always clean them first with IPA. The secret to soldering is really just preparation, and a clean board is the first important step. Stephen provides some excellent instructions for the kit. First, we're going to install the Arduino Nano onto the board. The Nano came with the required headers to solder into the board. And the Nano is programmed and ready to go. The instructions say to solder the long side of the pins through the board and trim them down after soldering. The pin headers feel stiff in the holes, so should stay in position while soldering. To help the solder flow onto the metal, I'll be using some no-clean flux. As the flux heats up, it removes any surface contaminants that stop solder sticking to your work. The trick with soldering is to make sure that both the board and the component are heated at the same time. Gummy Terry agrees. Grabbing a pair of sharp side cutters, we clip the header pins to length. These can ping off violently, so wear some eye protection. The soldering this side looks good. But turning the board over shows that one of the header rows slipped out slightly. Next, we need to solder the Nano onto the header pins. I'll make sure that the Arduino is actually level while soldering. We can roughly tack the Nano at the right height with a temporary blob of solder. Then we use some more flux. I'm deliberately using a larger standard tip here. As I solder, I'm touching the header pin and the metal solder pad on the circuit board at the same time. I then feed the solder onto the joint where the board and the component leg meet. That looks pretty good, after my earlier mistake. It's nice and solid as well. Next, this capacitor. It's a 0.33 microfarad part. Solder flows towards heat, so get the iron in heating the pad and the leg. Next up, a 79L05 regulator. This will generate -5 volts up to 100 milliamps of current. Making sure the flat side of the T092 package matches the board, we can solder it into place. Electrolytic capacitors next, both 10 microfarad 50 volt parts. These are polarized. The white strip is for negative and the longer leg is for positive. This board marks the negative side with a white semicircle and positive with a small plus sign. Spreading the legs stops your parts slipping out. More soldering. A good solder joint will look like a small cone. Time for the snip. Snip, snip. Whoops. Now it's the turn of a couple of diodes. Diodes stop or reduce the flow of electricity in one direction, so it's important to match the line shown on the board with the line shown on the component. Again, matching the line on the board. The line shows the negative end of the diode. Spreading the legs, ready to solder. I must admit that I'm using leaded solder here. That's allowed under UK regulations because I'm not making a product for sale, and I'm out of unleaded right now. The board is starting to take shape. Next, we'll install the voltage converter. This efficiently converts positive voltage into negative voltage. We'll see what voltages the board produces later when we test it with a multimeter. Terry and Dave know that this part will fall out of the board, so have brought me some Smurf poo to help. You can't spread the legs on a chip like this, so the blue poo will help hold the chip securely whilst we solder. We'll speed up the soldering from now on. Look out, there's a gummy crew about. Taking off the tack shows a fine finish. One more of the 10 microfarad capacitors goes into the C1 position. Don't forget to observe polarity. Then a physically smaller 22 microfarad capacitor goes into the C2 position. The project is really coming along now. These LEDs are the pass or fail indicators. LEDs are diodes as well, so must be installed the right way, with the long positive leg on the right. The positive leg of an LED is called an anode, and the shorter negative leg is called a cathode. In case the legs have been cut short, the body of the LED also has a flat side to denote the negative cathode. Install it the wrong way and it won't light up. And the LEDs are installed. You can see the flat cathode side of the part here. Another regulator, this time a 78L12. This will provide positive 12 volts. With regulators, the 78 and 79 series parts output positive and negative voltages respectively. The 5 and 12 at the end of the part name tell us how much that voltage will be. Another 0.33 microfarad capacitor. Capacitors store energy in an electrostatic field. Farad ratings are how much it can store before it lets go and charges again. A voltage rating on a capacitor is not how much it outputs, but how much it can tolerate before going pop. Power jack time. Don't put the blue tack on any part that will get hot. It'll go a bit melty. This is a much bigger part, and saps a lot more heat from the soldering iron before the part is hot enough to take the solder. Because this part will get a lot of physical insertions, we need to make sure it gets a really good amount of solder to give it mechanical strength. That looks really good. Positive sign is when the solder has formed a strong joint on both sides of the board. Now the part you've all been waiting for, that SMD soldering. These 4 resistors need to go on the underside of the board. R1 and R2 are 220 ohm resistors, and R3 and R4 take 1 kilo ohm parts. They're a bit fiddly, but easy enough if you take care. Tear back the tape to release the wee beasties. Flux is a must for this. Using tweezers, place your parts. Any way around is fine for these, they're not polarised. Once you're happy that you've put your part in the right place, hold it in position with the tweezers and dab it with the soldering iron that you've preloaded with a small amount of solder. This will hold them in place, but you can reposition them if you're OCD like I am. Note that if you overwork the solder, the flux will burn off and the solder will start to peak. Adding some more flux will help the solder flow properly again. I'm breaking the rules a bit with my massive tip and letting the component and solder transfer the heat to the board, but on a very small component like this it's okay. A bit over soldered, but functional. Now for the 1 kilo ohm resistors. All the parts were helpfully labelled by PCB geeks. It's pretty much the same again. Place your components. Then line them up like an obsessive person. Flux. Oh, I love a bit of flux. And learning from last time, I've loaded a bit less solder on the iron. And those look much better than the others. We can pop the switches in the board now. These tactile switches will only work if you put them in the right way around. Luckily, they'll only fit in the correct way due to being slightly rectangular. Push them in firmly and they'll hold the board very well. Like the power jack, these buttons get a lot of finger action, so be sure to give them a good solder joint. As I solder the last button, the Gummy crew have brought the last components to be soldered. When you solder your ZIF socket, be sure to put the lever up, otherwise the pins will be on an angle. We'll place both of these into the board at once. A smidgen more Smurf dung to hold them in place. And a good basting with flux once again. You can't have too much flux. I'm soldering the opposite pins on the sockets first. Sometimes as you solder, your part can slip out of the hole. Before you know it, it's gone wonky. And no one needs a wonky part. I really hope you're enjoying my video. My channel is driven by my kind patrons. If you're able to assist, even the smallest amount helps massively. Visit patreon.com/MarkFixesStuff for details. You'll get ad-free access to my future videos as well. Looking good, I think. With the sockets firmly installed, we can remove the sticky stuff. And the build is done. Time to clean up my act. Thanks, chaps. Ooh, sticky. With a soft, bristled toothbrush and some isopropanol alcohol, we can remove the flux residue. With the board clean, we can use our rubbers on the bottom. These are sticky little beggars and should stop the board sliding around on the bench. Oh, that's no good. Ah, the solder tabs at the socket are protruding. Let's just snip them off. Again, use eye protection. Perfect grip. For power, we need a 9-volt power supply with the centre pin positive. These are fairly common, but of course I can't find one right now. I'll just use my bench supply wired up appropriately. A bench supply is a very handy tool indeed. My chewy chums are always keen to help out. I can take it from here, gentlemen. The LED's light, which is a good sign, I think. Although we have both the LEDs lit, I'll play it safe and check the voltages are right for the memory chips. For the 4116, we have -5 volts on pin 1, plus 12 volts on pin 8, positive 5 volts on pin 9, and ground on pin 16. Placing the black lead on ground, we check pin 9 for around 5 volts. Then we check pin 9 for roughly 12 volts. And pin 1 for approximately -5 volts. With those OK, we just need to check for 5 volts on the 4164 socket. Ground is in the same position. And that's about right as well. Let's test a 4116 chip. Making sure the notch is towards the white arrow on the top of the tester, hold the chip in position and close the lever. Then we press the button. The Arduino sends 0s or 1s to each memory location on the RAM chip, then reads back the value to see if it matches the 0 or 1 sent. The code runs 4 test cycles, first writing and reading just 0s, then just 1s, followed by a 0-1 pattern, and finally ending with a 1-0 pattern. Let's try a 4164 chip. The tester checks that the chip can be written and read, so it's more of a bad chip finder than a good chip tester. Both chips passed, but were known to be good. Let's try some of my AliExpress bargain specials. First, a suspiciously marked 4116. I suspect this will fail, but if it passes the tests, I'll test it in a real machine in a later video. And, well, it's not failed immediately. I'm shocked. But it passes the read-write tests. Now to try a 4164. Surely I can't be lucky again. After the test, we're all shocked to see another pass. I got suspicious, so I decided to blow up a 4164 in the 4116 socket. Boom! 12 volts of death and an immediate fail. Now we can try and test that in the 4164 socket. Immediate fail, and we know that we've burned this chip out. Just reseating and trying again. And it starts the process and then fails again. It's dead. Well, this is a really useful and easy to build project. You can buy the kit from PCBgeeks.com and even pre-built if you're feeling lazy. Massive thanks to my amazing Patreon supporters who make my videos possible. You can join them at patreon.com/markfixesstuff. Thank you so much for watching my video. Perhaps you'd like to watch another one. Here, there's some on the screen for you. Bye!